Alright, how's everybody doing out there in Math Magic Land today? It's Miss Muscarella coming at you, and in this video, we're going to take a look at solving radical equations. The first type, where you have a variable that's a factor, and that variable is not underneath the radical. And in case you forgot, a radical is like one of these things, a square root, or maybe it's something to a cube root. Alright, so that variable is not going to be underneath this little area right there, so no variables in there for this one. Alright, so now on to our show. Let's take a look at the first example. So here in our first example, we are going to take a look at the problem. X plus 1 equals x square root of 2. Now, you've got a series of steps that you're going to do, and this is just like solving any equation. You want to get the variables on one side and everything else on the other side. So this x that's on the left-hand side, I'm going to want to move that to the right-hand side. So when I do that, I'll have 1 equals x square root of 2 minus x. The second thing that I want to do is go ahead and factor out the x. On the left-hand side, I'll have 1. On the right-hand side, I'm going to factor out the x, in which case I'll have square root of 2 minus 1. Now the third thing I'm going to do is I'm going to divide both sides by the square root of 2 minus 1, because I want to isolate my variable x. I want to get rid of that so that it is by itself. So square root of 2 minus 1 is what I divide both sides by. Now I'm going to switch sides here for a second, but basically this whole piece, that and that, they're gone, they cancel out. So I'm going to move the x over to the right hand or left hand side, and then the 1 over square root of 2 minus 1 is going to go on the right hand side. Now, math people, we don't like it when we have square roots and stuff in the denominator, so we got to change that junk. So here's what we're going to do. We're going to rationalize this thing. So in the rationalize, what we're going to do is find the conjugate of square root of 2 minus 1, which is just square root of 2 plus 1. And square root of 2 plus 1. So just kind of as a quick review, when you multiply conjugates together, it's kind of like multiplying something like this, x plus 3 times x minus 3. If you know what happens when you do that, the x and the x, you'll just have an x squared for that. But then when you multiply the outside and inside terms, they're gone. So you just multiply the 3 and a negative 3 together, and you just have this minus 9. So that's going to be very, very similar to the process that you use when you multiply a conjugate. So let's take a look at what this one would look like. So you're going to have x equals, in the numerator, you're just going to have 1 times square root of 2 plus 1, which is nice. Square root of 2 plus 1 is in the numerator. In the denominator, so your first term, the x, or square root of 2 times square root of 2, when you multiply those two terms together, of course, you know the radical is going to go away. You're just going to be left with 2. Now, the last term, the minus 1 and plus 1, when you multiply these two guys together, so plus 1 times negative 1, that's going to give you a product of negative 1. And then we know 2 take away 1 is, of course, 1. So the answer that we'll get will be square root of 2 plus 1, all that over 1. Well, since it's over 1, like, we don't have to write that because, you know, we're math peeps and we don't have to worry about that. So we could just leave that as square root of 2 plus 1. Boom. There's our answer. But, of course, like any good math problem, we'll know that it's right. We'll know that it's exactly right by checking our solution. Now, since I have an equation, that means I want to get the same thing on both sides. So wherever there is an x, I'm going to substitute in this square root of 2 plus 1. So first, we're going to write the word check, because that's how you tell somebody that, hey, yo, look right here. This is where my check is. So you want to check yourself before you wreck yourself. Second step, I'm going to write the original problem. So I have x plus 1 equals x square root of 2. Third step, plug in a value that we got for x. So in this case, we got square root of 2 plus 1 for x, and then plus 1. And that's going to equal square root of 2 plus 1, all of that multiplied by square root of 2. Now, square root of 2 plus 1 plus 1. So these two guys right here, boom, boom, those two are going to be, just give me a sum of 2. So I'm going to have square root of 2 plus 2. On the other side, so this is where you got to be careful here. So on the other side, you're going to have to take this square root of 2 and you're going to multiply it by each one of these two terms. When you do that, of course, square root of 2 times square root of 2 is just going to be 2, and square root of 2 times 1 is going to give me just square root of 2. Now you'll notice I have the same thing on both sides, and it doesn't necessarily matter that they're in a different order, because the commutative property of addition states that I can change the order I'm adding, because, you know, that's algebra 1 stuff, we remember that. So I could change that order and go 2 plus square root of 2, and that way it'll identically match what is on the other side. But you don't have to do that. You could leave that right there because you're not in Algebra 1 anymore. All right, so that's how you solve a problem involving radicals. Let's go ahead and take a look at another example, and then I'll give you one to practice on your own. All right, so here's example 2. Check this out. So there's 3x on the right-hand side. We're going to get that over to the left. So I'm going to have x squared of 3 minus 3x equals just plain old 5. Next, I'm going to factor out the x. X times the quantity square root of 3 minus 3. All of that still equal to 5. Then I'm going to divide both sides by square root of 3 minus 3. So that'll end up giving me x equals 5 over square root of 3 minus 3. And of course, you know, we don't like that square root of 3 minus 3. So you multiply by the conjugate of 3, square root of 3 minus 3, which is square root of 3 plus 3. So square root of 3 plus 3 in the numerator and denominator. And that is going to give me 5 times square root of 3. That's just 5 square roots of 3. Now 5 times that 3 over there is going to give me plus 15. So 5 square root of 3 plus 15 is what's in the numerator. And remember, the denominator, so in the denominator, square root of 3 times square root of 3, that's just going to give me 9. And then when I have negative 3 times positive 3, so these two guys right here multiplied together, that of course is going to give me negative 9. Oops, I was thinking too fast here because I was actually thinking ahead. So square root of 3 times square root of 3, duh, that's just going to be 3. And then square root of 3, or negative 3 times 3, that's going to give us 9. So I'll have 3 minus 9 in the denominator. Now, of course, 3 minus 9 is, that's right, negative 6. So I'll have 5 square root of 3 plus 15 all over negative 6. Now this can be written a couple of different ways. So you could actually write it like this, where you take this little negative sign and you could write it out here. So you might write it as minus and then 5 square root of 3 plus 15, all that over 6 like that. So the negative is kind of like kicked out in front by itself. Or the last way that you could write it, so there's one other way that you could write it, and that would be if you flip the signs of everything at the top and then made the 6 positive on the bottom. So you'd have negative 5 square roots of 3 minus 15, all of that over 6. So those are 3 different ways that you could write it. You write it like that, like that, like that. Either way is A-OK. All right, now to do this check, this one's going to take a little bit longer because we've got a fraction going on in here. So first thing we're going to do is write the word check, and then of course we'll write down the original problem. X square root of 3 equals 3x and then plus 5. Now the first thing we'll do after that is we're going to substitute, I'm going to go with the very first version of the x that we got, 5 square root of 3 plus 15 over negative 6. I'm going to substitute that in for x. So I'm going to have 5 square root of 3 plus 15, all that over negative 6. That is going to be multiplied by square root of 3. On the other side, I'll come to the other side here in a second. Let's just clean this guy up. So 15 times square root of 3 is 15 square roots of 3. And then if I multiply 5 square root of 3 times 3, the square root of 3 times square root of 3 part's going to cancel out and just give me a 3. So I'm going to have 5 times 3, of which of course we know that gives us just 15. So I'm going to have 15 plus 15 square roots of 3, all of that over negative 6. That's what the left side is going to give me. Now let's see what we end up with on the right side. So on the right side, same thing. I'm going to take a 3, and this time for x I'm going to put in 5 square root of 3 plus 15, all that over 6. So 5 square root of square root of 3 plus 15, all that over negative 6, and then don't forget this plus 5 over there. Now if we distribute the 3 to each one of those two terms, I will have 15 square root of 3. Ooh, I like that because that kind of matches one on the other side. And then 3 times 15 gives me 45. So plus 45, all of that over negative 6. And then don't forget, we still have our lonely little plus 5 out there. Now, if I want this to have the same denominator on the right-hand side, then I've got to make sure that what I'm going to do basically is look at the denominator on the left, or on the right-hand side, which is negative 6, and I'll multiply that by 5. So I can change that 5 and get a common denominator there. So I'm going to have 15 square root of 3 plus 45. Then negative 6 times 5 is negative 30. And then all that I can put over the same denominator, which of course is negative 6. And then what we're going to do is just clean up. We're going to do a little cleanup here. Oh, I'm liking this. This is going much nicer. Because see these two guys right here? What do? When I combine those, of course, I will get 15 square root of 3 plus 15. All that over negative 6. And is that what's on the other side? Booyah, it is. Now, just as a point to keep your work nice, neat, and organized, make sure that you write the same thing all the way down on the left-hand side as well. So 15 plus 15 root 3, all that over negative 6, and then 15 plus 15 square root of 3, all that over negative 6. So that way you have the same thing on both sides. You get to that, and we're good to go. Alright, you guys have made it this far. You've got one more problem to try on your own. So let's go ahead and do 3x minus 2 equals x square root of 2 plus 4. And when you get done, pause the video and then come back, check it out, see how you did. Alright. How did my rock star do? Yeah, I'm sure you guys got this one right. So you should end up with 18 plus 6 square root of 2 all over 7. Now, just kind of as a side note, be sure when you're taking a look at that, you might look at this number, and the number in the denominator. Just make sure you can't reduce that at all. Because every once in a while, you'll get one where you can. So be sure to simplify early and often when you do these kind of problems. Alright, that's it for this video, you guys. Thanks for watching. I'll catch up with you on the next one. Peace out.